Today's lesson is writing equations from tables, and so to begin, we first need to think about rate and y-intercept. When we think about rate, we know it is our m value when we have that generic equation y equals mx plus b. It's always our m value. We also have a couple different ways of thinking or calling it. You also might hear slope, change of the y values over the change of the x values. When we are talking about graphing, we'll say rise over run. And ultimately, it's always the coefficient of our x value. So when we think about the coefficient, it's that number in front of the x value in our equation. We also have a few ways of thinking about the y-intercept. In that equation, we know our y-intercept is that b value. And it's where the line crosses the y-axis. So if we look at a graph and our line is here, it's that point where it crosses our x-axis. And we know we could write a coordinate for that point of 0 something. And that something would be our b value or our y-intercept value. Those are all different ways of thinking about the same concept. So when we want to write an equation when given a table, we have to find two things. First, we're going to have to find the slope, and then we'll have to find the y-intercept. To find slope, we're really going to focus on that change of y over the change of the x values. If we focus on that thought for slope, it's going to really help us when identifying our slope. So change of y values. Notice the y's are on the bottom. And so we want to show our thought. So 0 to 2, when I'm going from 0 to 2, that's a change of plus 2. I went up 2 units. 2 to 4, I'm adding another 2. 4 to 6, adding another 2. 6 to 8, I add another 2. In any part of this problem, my change of y values was adding 2. We then want to do the same for the change of our x values. And we want to show that same process of our thoughts. 0 to 1, add 1. 1 to 2, add 1. 2 to 3, add 1. 3 to 4, add 1. In every case, our change of x's was adding 1. And so now, we just found our slope. Positive 2 over positive 1, 2 over 1, or 2. We can also use this table to find our y-intercept. Remember, y-intercept on a graph is where it crosses the y-axis. This is the point 0 something. So for the y-intercept, we look for when your x is 0. And I can look at this and I actually see my x value is 0 right here. I have the point 0, 0. So my y-intercept is that y value in that ordered pair. My y-intercept is 0. And so now I can write my equation. Y equals 2x plus 0. Well, we don't really like to write 0, so we would just say y equals 2x. And I have my first equation. On some tables, we can just look at it and identify that y-intercept, but that's not always going to be the case like in this next problem. So to begin this next example, we're going to do the same to identify the change of y over change of x. Instead of writing out the words change of, you might see me use the sign delta to represent the change of y over change of x. Looking at my y values, 13 to 22, I add 9. 22 to 31, plus 9. 31 to 40 is plus 9. So every time my change of y went up by adding 9. Now we look at the x's. Remember, x's are on top. 1 to 2, plus 1. 2 to 3 plus 1, 3 to 4 plus 1. So my x's every time went up by plus 1. 9 over 1 is my slope, or just 9. Now, unlike our first example, I can't just look at this table and see where x is 0. When I look at this table, when I look at the x's, I only have the numbers 1 through 4. I don't have 0, but that's not going to stop us. I can work backwards because I know if I go backwards 1, it would land me at the point 0. So I did the opposite, so I have to go backwards. Instead of adding 9, I would have to take away 9 units. Well, what plus 9 would get to 13? 4. It's still following that same pattern if we move the other direction. 4 plus 9 is 13, and 0 plus 1 is 1. So now I have my y-intercept. Of the point 0, 4, the y-intercept is that y value of 4, and now I can write the equation. Y equals 9x plus 4. We have a few more examples, and it's always going to be identify your slope first. So, how are your numbers changing? In this case, my numbers are actually going to get smaller when I look at the change of my y's, so we're going to be subtracting instead of adding. From 790 to 223, I can throw that in my calculator to figure out what the difference is, but I'm subtracting 567. Find the difference between my next two numbers, and once again, subtract 567, and once again, I subtract 567. You can use your calculators to help you figure out that difference if you need to. Now that I know the change of my y is negative 567, I now need to figure out the change of my x values. 0 to 1, add 1. 1 to 2, add 1. 2 to 3, add 1. My change in my x values was adding 1. Negative 567 over positive 1 simplifies to negative 567.
Nicholas Rosh.
I then need to see how I can identify my y-intercept. Remember, y-intercept, we're looking for the point 0 something. When that x value is 0, I can see the y-intercept. When I look at my table, I see x is 0 here, and so I am easily able to identify my y-intercept is 790. Now that I have those two parts, I can write my equation. Y equals negative 567x plus 790. Next, we have our table, and I would like you guys to pause the video and find the slope on your own. Remember, you're finding the change of y over the change of x. So pause the video, find the slope, come back and check to make sure you did that correctly. So if you calculated your slope, your paper should look similar to mine. You're showing the change of y values, you're showing the change of x values, and then we figured out it was 1 over 1, which equals just 1. Now our next step is to find the y-intercept. Remember, with the y-intercept, it's the point when x is 0 and whatever value that gives us. When I look at my x column, I don't have 0. So once again, just like on the front side of your nose, we have to work backwards. I need to figure out if x was 0, what would that corresponding y value be? And we're going to keep following that pattern. Well, to go from 0 to 1, I just have to add 1. So I'm actually going to be able to do the same pattern. What plus 1 is 0. You could work backwards, subtracting 1, and subtract 1. Well, if I subtract 1, I end up with negative 1. So my y-intercept in this case is negative 1. I can then write my equation, y equals 1x minus 1. We don't need to write 1x. It's not wrong, but a better answer would be y equals x minus 1. Both of those equations are the same thing, but this bottom one is a little better because it's more simplified by not putting that 1 in front of our x. Now, our last problem is similar to what we've been doing, but it's a little different in this case. Once again, we're going to start by finding the change of y values and the change of x values. Remember, y values always go on top. So 19 to 15, I'm minus 4. 15 to negative 2, minus 17. Negative 2 to negative 19 is negative 17. My change of y isn't the same in every jump, and so I don't want to start thinking about my slope quite yet because we're going to have to do a little more math. But I can also find a change in my x values. Negative 19 to negative 15 is plus 4. Negative 15 to 2 is plus 17. 2 to 19 is plus 17. So what we're going to do is we're going to actually think about each of these as individual slopes. So my first change of y over change of x was negative 4 over 4. Well, that's just negative 1. My second two were the same. They were negative 17 over 17. Well, that also is just negative 1. So even though our graph changed by different values, the slope was still the same. In both situations, I had a slope of negative 1. So it might not always change consistently, but it's still going up by that same rate or that same slope. You need to make sure you check that though, because sometimes it may not change correctly and it might not be a linear graph. We still though have to find that y-intercept. So we're looking for the point 0 something. Now, if I found 0 in this table, it would sit in here. And you guys might be able to see an observation. Negative 19, 19, negative 15, 15, to negative 2. The x and y are opposite values. X and y are opposite, x and y are opposite. And so by logical deduction, if 0, well, the opposite of 0 would just be 0. So my y-intercept is 0 in this case. And so then I can write the equation y equals 0. Oh, no. mx plus b, negative 1x plus 0. As we've said before, we don't really write plus 0. It's not necessary. And we don't necessarily have to write this 1. A more simplified version of this would be y equals negative x. This would be the best answer. If you want to write negative 1x, not wrong, just not the best answer. So sometimes you have to work to find your y-intercept, but you're looking for when your x value is 0, and then you'll find that to write your equation.